Good morning, everyone. In the last class, we discussed about dynamic routing. And in the dynamic routing, we have discussed that we have distance vector, link state, hybrid, and in EGP, we have path vector, and under that, we have a protocol that is called as a BGP. Correct? So yesterday, we were discussing about routing information protocol. Correct? So we discussed the routing information protocol is a distance vector protocol that uses number of hop count as a metric to calculate the best path between the source and destination. Then it is going to have different versions like version 1, version 2, and next generation. So this both are for IP version 4, and this is for IP version 6. Next, this has version 1 and 2. So version 1 supports broadcast. It means it sends update using broadcast address. Now it supports only glassful network. Correct? Whereas version 2 sends update using multicast address. Correct? No? Apart from that, it supports what? Classless network. And multicast address that it uses is 224.0.0.9. Correct? Now, this routing information protocol is a which layer protocol? It is a which layer protocol? It is a layer 7 protocol. Yes, application layer protocol. The reason? It uses port number 520 UDP. That's why it is a layer 7 protocol. Routing information protocol uses port number 520 UDP. That's why it is a layer 7 protocol. Okay. So we have discussed all these things about this RIP, and even we have done the configurations. Today, just I will discuss about the EIGRP. We will not do any configuration of the EIGRP. Then we will compare with EIGRP and we'll do the configuration of the EIGRP. Okay. Because this EIGRP has been removed and now we are going to use only EIGRP. Right? Now understand first the differences between EIGRP and RIP. See, EIGRP is also a distance vector protocol only, but the difference is it is Cisco proprietary. It means this protocol was developed by who? Cisco. Cisco feature it is. Now it is telling you that here the distance vector protocol, correct? No? But the metric compared to RIP, though RIP is also a distance vector only, but RIP uses only one factor to calculate the best path, that is number of hop counts. Whereas EIGRP, though it is a distance vector, but it also includes other factors to identify the best path apart from number of hop counts. That is what? Bandwidth. That is delay, load, and reliability. Means apart from that number of hop counts, it uses bandwidth, delay, load, and reliability as a metric to calculate the best path. What is this everything bandwidth, delay, load, and reliability? We'll come to know about when we will start the EIGRP at CCNP level. Okay. Now, see what happens that it sends updates every 90 seconds. Your RIP was sending updates every 30 seconds. So compared to that, it sends every 90 seconds, right? Now, the demerit again for the EIGRP is that it supports only classful, no classless, correct? So does not support variable and subnet mask, or we can say classless interdomain routing. And in the case of RIP, the maximum hop count was 15, correct? No? But in this EIGRP, the maximum hop count is what? 255. Right? Compared to what we can see in the RIP, it is going to give you more information, more number of hop counts.
So what is about default?
Default is 100. By default, it will be supporting 100. Maximum, it can go for the 255. We can change that part. Convergence slower compared to modern protocols. It means whatever the other protocols that we have now, Compared to it, this IGRP is slowest. Slow. What is the AD value of IGRP? 100 is the AD value. Now what happened that as you are knowing here that it is going to support class full, but in the year 1990, classless network came. When around in the year 1990, classless network came. So we were having several other protocols that was supported by classless network. But as this IGRP was not supported this, that's why Cisco developed one more protocol that is called as a EIGRP. And this is what? Enhanced Interior Gateway Routing Protocol.
What's classless also?
Right? It supports classless also. Now see the differences between them. So it is written here that EIGRP is what? Enhanced Interior Gateway Routing Protocol. What is the type? It says it is a hybrid protocol. It means it is going to combine the feature of distance vector and link state protocols. It means it uses both the metrics, distance vector also and link state also. Then see what it does. It is telling you that use the same composite metric of as IGRP only, but with the additional enhancement. Means it also uses bandwidth, delay, load, reliability, and you can add one more point that it uses even MTU. Okay, MTU to maximum transmission unit. It uses all this factor or metric to identify the best path. Okay, when you will come to the like CCNP level, you will come to know that in EIGRP we have certain thing that is called as a K values. Okay, so K1 is representing bandwidth like this K2, K3, K4, and K5. Correct? So it says here that it is going to use same composite metric as IGRP, but with what? Additional enhancement or additional features in that. Correct? Now, it says that what is the algorithm it uses? It says it is using diffusing update algorithm, or we can say dual algorithm. What does it mean? That here it is going to have two things. One is successor and one is called as a feasible successor. It means it will be having one best path and one second best path to reach a particular destination. That's why it is calling here as what? Dual. To reach a same destination, it will be having one backup. Correct? So if one is not working, what will happen? It will select the other path. So one best path will be called as what? Successor. And next one is called as what? Feasible successor. Fine. Now, it sends updates. Say it is what it is written. Does not send any periodic updates. Correct? No? It means it will be sending the updates only when there is change in the network. When there is a change in the network, that update will be delivered, not all the updates. Compared to what we had in the RIP, it was sending all the update every 30 seconds. It is not going to send every 30 seconds or 90 seconds. What it does, it sends update only when there is change in the topology, making it more efficient. If changes are there, it will send. If no changes, it will not send. If changes are there also, it will send, but using what? Same multicast address, not broadcast address. Correct? Now, it support what? Here it is written that it support classless network, classless port. Supports VLSM, CIDR, allowing more flexible submitting. Maximum hop count is what? 2 to 4. Default is 100. Now, convergence, it says it is much faster due to dual algorithm. What is the AD value of EIGRP? 90 is for the internal and 170 is for the external. And when it supports what? Authentication and provides enhanced security. Classless interdomain routing. Like we have discussed, no, that for class B, we have 16 to 23. These are the CIDR values. Okay. Now for authentication purpose, what it uses? MD5 HMAC SHA 256. Okay. This is message digest file. Again, same thing. You will come to know about this in CCNP only. Correct? Now, which one is the most fastest protocol? EIGRP is the fastest protocol. And which one is the slowest? Which one is the slowest protocol? BGP. Border Gateway Protocol. BGP is the slowest protocol, but most reliable. Means it considers reliability as a factor, not speed as a factor. Correct? That's why. But this one, as soon as you will configure it, it will form the membership. That's why it is very fast. Yeah. And it also uses dual algorithm. That's why it is very fast. Fine. TCP. Clear now till here? Which one? EIGRP layer 3 protocol. Or we can say not exactly layer 3 because it does not uses TCP. It uses different protocol. The protocol developed by Cisco only. Okay. So if you want to see which protocol, it uses reliable transport protocol, RTP, to manage sending and receiving of the routing messages. And RTP is layer 4 protocol of what? Cisco. Like how we have TCP, like that. Right? But we can say EIGRP as a layer 3 protocol. What is the multicast address it uses? 224.0.0.10. Correct? You have to remember all these multicast addresses. Now, let us configure EIGRP. One 192.168.1.1/24. 192.168.1.2/24. This side we have is a 10.2.2.2/24. 20.2.2.2/24. Fine. Two network we have this side. So from router 1, you want to reach this network. Okay. And let's say here also we will take one network, 10.1.1.1/24. Okay. And 1.1.1/24. Come to this router. CLI give no. Enable config space T. Host name is what? Router 1. interface G0/0. Now IP address is 192.168.1.1, 255.255.255.0. Give no shut, give exit. Interface loopback 1, IP address is 10.1.1.1, 255.255.255.0, give exit. On interface loopback 1, same as interface loopback 2, IP address is 1.1.1.1, 255.255.255.0, give exit. Then do show IP interface brief. Here we have configured the IP, right? Same as come to router second. Enable config space T. Host name is R2 and interface G0/0. IP address is 192.168.1.2 and 255.255.255.0. Give no shut. Give exit. The interface loopback 1. IP address is 10.2.2.2, 255.255.255.0. Give exit. Next interface loopback 2. IP address is 20.2.2.2, 255.255.255.0. Give exit. Now you check do show IP interface brief. Then same if you will try to ping it from first router this network, it will not ping. Same as if you will try to ping it from this router to this network, it will not ping without routing. So we'll do here routing. Okay. Now, if it will like whenever you will configure here, no. So it is going to ask you one AS number. So consider that this router, both the router is in our autonomous system number, and that is going to be 100. Because it will ask you to put the AS number there. So come to router, give your router EIGRP, and now you give enter. What it says? Incomplete command. It means after EIGRP that we have written, something we have to write. So when you will write again, and if you will give a question mark, what it says, what we have to write? Autonomous system number. And what is the range of that? 1 to 65,535. See, this is Cisco packet tracer. That's why it is showing you till here only. It means it is showing you till means 65,000 only. But in the real scenario, it has been changed now. It is going to be 2 to the power 32. That many size we have now, not this till this one. Okay. So new range you can expect. It means within a new range. Yeah, this is a new range. So earlier we were having till 65,535, but now it has been changed to this one. This many total AS number is possible now. Okay. Updated version we have this. So whenever anyone is asking you what is the range of the AS number, you have to tell this one. It means 2 power 32. Correct, no? Now come to this one. So we will write here what? 100. After that, what we have to write? Network. What is the network? 192. Or let me write one more thing. No auto summary first. Okay. Here it is required. When you will come to that EVNG, it is not required there. Then network 192.168.1.0. See what it says. What it says? It says you to write wildcard bits. Even if we don't write here, there is no such problem. It will take without that also. But when you are coming for OSPF, it is mandatory there to write the wildcard bits. So after this, we'll understand what is that wildcard bits. Then network one more, that is 10.1.1.0. Correct? One more network, 1.1.1.0. Done. So what we have done here, whatever the network that was associated with this router, we have advertised the same network. Correct? Same we have to do it with the second router as well. So right here router, EIGRP, and ACE number should be same, 100. Next, network is what? 192.168.1.0. It means this is a common network. See, just I have given the command, just I have entered the common network and it formed the neighborship. What it says, neighbor with 192.168.1.1. It means new adjacency has been formed between them. Next, we will advertise the other networks. That is what? 10.2.2.0. The network is what? 20.2.2.0. Give exit. Now, come to router first. And give command do ping 10.2.2.2 and see it is pinging. It's there in the background. Sometimes it does not source. Pinging, no? Now, when you will verify, do show IP route. See here, what is it in? D. D for EIGRP. EIGRP. Okay, same as you can see it here. 20.2.2.0/24. And what is it in here? D. D for EIGRP. Now question, why D? See, like for RIP, we have seen R was written. For static, S was written. For OSPF, O will be written. But for EIGRP, D is written. The reason, because E is already reserved for the EGP. That's why. Okay. And even it supports what? Dual algorithm. But the main reason is because it has been reserved. Correct? No? Now see, what is the AD value? 90. Same as here also. Now why it is having AD as 90? Because we have used common AS 100. Both the routers belong to a same AS numbers. So it is internal EIGRP and the AD value of internal EIGRP is what? 90. And this is what? Metric cost. Right? Yes. Now, how it is going to calculate the metric cost? Just I will show you, will not explain. This is a formula, and based on this formula, only this metric cost has been calculated. Okay, though here it seems very like complicated, but it is very simple. Okay, and these are not there in the CCNA, CCNP syllabus. Okay, so based on this formula only, here the metric cost you have got, and this one. Correct? No. Now same we can write from the other side also. Do ping 10.1.1.1. Yes, it is pinging. Now you check do show IP route, and here it shows. Clear? Do show IP. So these are the commands we have given. Correct? So write down the command for the EIGRP now. So EIGRP is what? Enhanced Interior Gateway Routing Protocol. It uses both distance vector and linked state as a metric to calculate the best path. Fine. It uses, or we can write that it uses dual algorithm. It sends update using multicast address of 224.0.0.10. It does not send periodic updates. Sends update only when there is any change in the network. And what is the command? Router EIGRP, then ASN number, then network, that network address, and that's all.
When you type the network command,
Hmm.
what do you
Hmm?
you type
Hmm.
what is
Means here we have to write network address, no? Network address we have written. Then it will start sending the messages, hello packet messages. Hello packet messages it will send, no? And when it sends hello packet messages, like hello timer in the EIGRP is 5 seconds. Every 5 seconds it sends hello packet message. It will wait for the hold on timer till 15 seconds. If it is unable to get any reply from the neighbor, it will tell you that my neighbor is down, it is not working. If it is receiving the hello packet messages from the neighbor, it means both are active, they will change the network information. Okay. So it is based on what? Hello packet messages. And we can even change that timer also. Hello timer or hold on timer, everything. So by default, you can write it here. Hello timer in EIGRP is 5 seconds. And hold on timer is 15 seconds.
Sir, how will we get to know ASN when we are accessing real devices?
So we will get that information. Yes. Clear? So this we complete EIGRP here. So we have to discuss EIGRP in detail in the CCNP level. This will take around 1 week to complete EIGRP at CCNP level. Now we'll start with the OSPF. Till here it is clear. Any doubt, any questions? So what is OSPF? It is open shortest path first, and it is a link state protocol. So OSPF is open shortest path first. It is a link state protocol where link means what? Link means interface or connection point of the router, and state means what? How it is connected or how it is behaving. For example, we have a connectivity interface we have. Now that interface connectivity is established. Now what type of connectivity is there? It means that port, that interface is either gigabit, fast Ethernet, depends upon what? Like again speed. So if it is fast Ethernet, it will give you 100 Mbps speed. Gigabit, it will give you 1000 Mbps speed. That's why in this, it is dependent upon what? Link state. How you have connected the devices. Correct, no? And how it is behaving. Apart from that, like how it is connected and how it is behaving, one more thing, whether interface is up or not, or we can say a status of the interface. If your interface is down, it is also a state of that. If it is up, it is also a state of that. Right. This is also, we can write this, a status of the interfaces. So OSPF uses metric cost to calculate the best path, where cost is equal to reference bandwidth upon interference bandwidth. This is a formula to calculate the cost in the OSPF, where it is going to use what? Reference bandwidth upon interference bandwidth. What is reference bandwidth? Reference bandwidth had a value reference bandwidth by default we can take is 100 Mbps. This is a default value of the reference bandwidth. Then interference bandwidth depends upon the types of connectivity that we have taken there. Interference bandwidth is what? The type of interface that is used. Now, for example, let's say the interference bandwidth is equal to fast Ethernet. So if it is fast Ethernet, what is the value? 100 Mbps. Okay. So cost, it will be what? Cost is equal to 100 upon 100. That is going to be what? If interference bandwidth is not fast Ethernet, but gigabit Ethernet, then it is going to be 1000. And when we will calculate the cost, we will get 100 upon 1000. Right now, the least cost, best path, right? So least cost is the best path, but it will maintain equivalent to as a one only. The reason, because it does not maintain it in the decimal form. Okay.
Vishal, you're on mute.
Yeah.
Now clear, no? Backup designated router. So DR is what? Designated router, and BDR is what? Backup router. So when you are sending any update from DR to other routers, you use multicast address, this one. But when we send update from other routers to the DR routers, it uses this multicast address. Okay. Now, what is the requirement for this DR? Why do we need this BDR? Everything we'll discuss. Okay. Because for that, we need to understand LSA also. Okay. So here you understand here that we have different categories of the routers in the OSPF. One will be called as what? DR. One will be called as what? BDR. And rest other router that is left will be called as what? DR other. These are the categories of the routers: DR, BDR, and DR other. Same, it is also going to send you what? Triggered update, or we can say partial update. Triggered update means what? Whenever there is any change in the network, that update will be self-delivered. That's why it says a triggered update. And that also partial update means what? Not all the update will be sent, only the changes update will be delivered. Correct? Now, OSPF has certain packet types. So we'll come to this packet types later on. First, we will discuss states. So OSPF has certain states. Total, how many states we have? 7 states. Now, why it is explaining all these states? See, whenever you will take routers, let's say we have a router. All the routers has been connected. If they are connected, so first, if we have connected, we have configured the IP. So they need to form what? Neighborship between them. To form this neighborship, they will be going through these different states. So whenever you take the routers for the first time, no configuration, just configuration has been done. So they will be in which state? Down state. And this is called as what? Initial state. It means when OSPF is enabled, like you have configured the IP addresses, everything, you have configured the OSPF also. So now what happened? OSPF has been configured, so they will be in which state? Down state, right? Means they have just configured it. So once it has been configured, so OSPF is enabled, but they will be in which state? Down state. That is called as the initial state. Or in this, it says that at neighborship relationship has been failed, not failed, we can say not started. Right? In the down state, neighborship has been not formed. Just OSPF has been configured. Next, it will come to which state? Init state. In the init state, what will happen? Routers exchange hello packet to determine the parameters like hello and dead interval timings. It means, let's say we have a router, it will send a hello packet message to its neighboring router. Same, that router will also send hello packet messages to its neighboring routers. If one side hello packet has been delivered to other routers, this is called as an init state. Init state, in this what happens? It is unidirectional. It means at present, both the routers has not seen each other hello packet messages. Let's consider we have a two friend. For the first time when you come for the class, you don't know each other, no? So you are there in down state, you don't know. Then you come to init state, you start sending hello. Hello, I am this, this is my name, right? So if any one person is sending the hello, other has not exchanged them. So it is called as what? Init state. Okay, now you told him hello. He also replied with hello. Then both the packet has been exchanged now. So they will come to two-way state. Two-way, in this what happens? Routers have seen each other's hello packet messages and agreed to become the neighbors. Correct? Now they have seen the both the means each other's hello packet messages. That's why they're in the two-way state. Now, in the two-way state only, one thing will take place. That is called as a DR and BDR election. What will take place? DR, and this is most important question in the interview. In which state of the OSPF DR and BDR election will take place? Two-way state. Where it will take place? Two-way state. Okay. Next. Next, what happens then if everything is done? Then I told you that what happens in the OSPF, they sends hello packet messages to determine whether my neighbor is working or not. So now for the first time he exchanged, so it was in the init state and came to two-way state. Now he knows that, okay, this is my neighbor, but he has to verify whether my neighbor is always alive or not. right? He has to communicate. So he will be sending hello packet messages every time. Not every time, every 10 seconds. Every 10 seconds, it will send what? Hello packet messages. It will wait for what? 40 seconds. If till 40 seconds he is not getting any reply from the neighbor, it will come to know my neighbor is dead. It is not working. You have to troubleshoot. Who will troubleshoot? Network admin will do. Correct? So once it is done, so it will keep sending the hello packet messages to determine whether my neighbor is alive or not. But in this case, what happens that if you have router 1, if you have router 2, okay, so router 1 delivered hello, router 2 delivered hello, they both become neighbor. Now they both will not send hello packet message. Anyone will send. Any one router will send hello packet message. It is not that router 1 will also keep on sending and router 2 will also keep on sending. No. Between them, master and slave election will happen. What election? Master and slave. This is different from DR and BDR. Don't get confused with DR and BDR and this one. Master slave is different thing. This between this R1 and R2 master slave election will happen. It means whoever router is going to have the highest IP address will be master. Second will be the slave. In this category, let's consider that R1 was having an IP on this interface as a 5.5.5.5 and R2 was having the IP, let's consider as 2.2.2.2. Which one is having the highest IP? R1. R1 will be the master. R2 will be what? And who will send the hello packet messages? R1. Who will reply? R2. Slave will reply. Okay. So in the external state, what happens? Master-slave relationship is formed. So routers exchange what? Database description packets to synchronize their link state database description. What is link state? See what it sent in the hello packet messages. It sends that, okay, this is my, this is about the information about the router itself. So it's connected interfaces, configured IP addresses, then router IDs information. Okay. Information will be delivered. What is router ID? What is the IP configured? Interface number, all this link state information. That's why it is sending here what? That it will deliver what? Link state database description packets. Once it has identified that, okay, my neighbor is alive, so I have to send all the link information to him. Correct? That's why here two things will take place. So in which state master and slave election will happen? Start. So you have to write here, in this master and slave election will happen. And router will exchange what? DVD packets. Then it will come to exchange state. In the exchange state, what will happen? Routers exchange all other packets, or it can send you that here it is sending you what? Link state request, link state update packets to request and send the missing LSS. See now what happens that whenever the router will send the messages to each other, they send in the form of LSA. What is LSA? Link state advertisement. Okay. So it sends the messages in the form of LSA, link state advertisement. So in this form, let's say, for example, this router 1 was having multiple neighbors. Consider here that this is a router 1. With this interface, it has connected with router 2. And with another interface, it has connected with router 3. Okay. So when router 1 will send the LSA, it will send via both the links. To the 2 also, to the 3 also. Because router 3 is also neighbor of router 2. And sorry, router 1 and router 2 is also a neighbor of router 1. So in what form it is sending you? LSA. If let's say it has delivered the packet, but some of the router has not received that, so that router who has not received will send it what? Link state request. Let's say you have exchanged mobile numbers. You have not received. What will you do? Tell me, send me again. I have not received, right? what you tell? Request. So if you're requesting, what will you receive? Update. Okay, that's what it says here, that it will request, it will get the update, okay, in the exchange states, whatever the missing. And in the loading state, what happens? Routers exchange remaining LSAs that were missing during the exchange states. So whatever that were missing, even in the exchange state, will be finally exchanged where? In the loading state. So when you will be coming in the loading state, it sends what? LSR, that is called as a link state request. Then ls update. Okay. Now see, if anyone has requested that I want this information, for that the router has delivered the update. So even it has to confirm no that yes, if I have requested for something, I have received your information. So finally, it has to send one link state acknowledgement. So one acknowledgement is delivered. It means it is telling it confirmation message that yes, whatever for whatever I have requested, you have sent it to me. I have got that. This is my acknowledgement confirmation message. Otherwise, what will happen? It will keep on sending that, considering that my neighboring router has not received the information. And once everything has been done, so they will be in the full state. Right? So full state means what? All the adjacency is fully established. Routers have synchronized all the LSDBs and can exchange the routing information. Correct? This is all the 7 states that we have in the OSPF. Okay. And see, total how many packets we have in the OSPF? 5 packets. States is 7, packet is 5. So the first packet it sends is hello packet. So see, hello packet is used for 2 things. This will be delivered for the first time as neighbor discovery. Hello packet has importance in 2 things. One is for neighbor discovery, and second is once the neighbor discovery has been done, so it is also responsible for maintaining that. Maintaining what? Neighborship. That's why it is written that it is used for neighbor discovery and maintaining the neighbor relationship. What it contains information such as router ID, area ID, network mask, and hello and dead interval timing. All this information will be there in the hello packet messages. Correct? It means that here you got certain extra information about what? Area ID. It means in OSPF, router will be belonging to a particular area. Okay. Even we'll discuss what is this router ID. Fine. So as I told you that once a hello packet has been exchanged, so next they will send what? Database description packets. Okay. So exchange the information about the content of the LSDBs during the adjacency formation process. It lists all the sequence numbers of the LSAs that router has it in the LSDB. All the information about the link will be delivered to the router so that it can identify what? The best path. So DVD packet will be exchanged, and where it is exchanged? In the start state, no? This will be in the init. Next will come to the two-way, and this will be in the extart. And then in the exchange state, what is there? Link state request packet. So it says request a specific LSA from the neighboring routers that are missing in the LSDB. See, whatever the theory part that we are discussing, it is very important to understand. Without this theory, you will not be able to do any configuration of the OSPF. Maybe neighborship has been formed, but you will not come to know how it is formed or how the information is being exchanged. So that's why we have to understand this theory part. And OSPF is the most important protocol, whether in the CCNA or CCNP. Question will be asked from OSPF. Maybe they will not ask any question from the RIP or EIGRP maybe sometime, but they will ask the question from OSPF. And these are the questions. How many types of packets we have, states we have, network types we have, LSAs we have. Okay. So please focus here. So this is what request. This is what update. What it says contains actual LSA in response to the request. In response of the update, request, we have got the update, and it says that it floods the LSAs. Floods LSAs means what? We'll come to understand, we'll discuss this flooding. And because of this flooding of the LSAs only, we have the concept of the TR and BDR. Flooding is what? Sending it to the all other ports. Even it does not require, it will send. Okay. Next, I told you we have what? Acknowledgement. This is what? Confirmation receipt of the LSU packets. And it prevents what? Prevents retransmissions of the LSA that has been already acknowledged. Clear? Okay, understand the scenario of the LSA first. What happens? Four router with a single switch. This is router 1. This is router 2. This is router 3. And this is router 4. Okay. Consider that router 1 has IP 10.1.1. This one has IP 10.1.2. This one has IPs 10.1.3. And this one 10.1.4. Now, all this router is a part of common network that is 10.1.1.0. So this is a network address for this particular IP, right? So all this 4 router is a part of common subnet. Now what happened? Let's say that there was any change on the router 1. Change on the router 1, maybe of the IP, maybe of the router ID, right? That change is there. So whenever anything is getting changed on the router 1, what this router 1 says that I have to update these changes to my neighboring router. Okay. So what it will do, it will send this update to whom? To the router 3, means via switch to the router 3. Next, it will send the same update to whom? R2. Wait. R2 and R4. Done. All the other router receive that change. Now what will happen? R2 received from R1 that on R1 there is certain change. R2 will think that if I have received this, I have to inform my neighbor. So R2, what it will do, will send it to R3, will send it to R4. Okay. Same as R4 will receive. R4 will think I have received one information from R1. I have to send my neighbor. Who is his neighbor? R2, R3. Same as R3 will think I have received certain information from R1. I have to tell to my neighbor. He will also tell to whom? Now you imagine the LSA flooding that is happening in the common subnet. If you have taken 4 router, this is a situation. If you have more numbers of router, what will happen? What will happen to the network? Always flooding of LSAs will cause what? Extensive load, extra load. More utilization of the CPU will be there. Higher consumption of bandwidth will be there, right? It means we have to control this flooding of the LSAs, correct? And to control this LSA flooding, we have a concept called as a DR and BDR. In that, what happens that among all this router, one router will be acting as a captain of that team. Okay. So whenever there is any change in a network, so that change will be delivered to the DR router. And just DR router will inform all other routers in that network. That's all. Done. Correct? That's why we have a concept called as a DR. So same thing, it is explaining you in the PPT slide also. See what it says. That here we have router 1. Right? On the R8, there was a change. So for that change, what this R8 did, it delivered the change to the R4 in the form of LSA. Same is to R6, same is to R7. Now, as soon as that information reaches to the R4, R6, and R7, they consider even I have to send this update to my neighbor. Deliver to whom? R3, R5, R1. Same as R3 will do, R5 will do, R2, then R2 will send, same as R5. So now you tell this R1 is receiving the same information from R7, from R5, from R2. Correct? What is happening here? LSA flooding is happening. Flooding of LSA will take place. So we have to control what? Flooding of the LSAs. Right? And see, here is explaining all these things. That here we have router 1, router 2. Router 1 is having one ID. Router 2 is having one ID. So they were in the down state now. So they started sending what? Hello packet messages. So they're in the initial state. Now, if they have seen each other, they came to two-way states. Then we have a starter state, and then we have a exchange and loading and full state. Correct? Now we'll understand how this particular election of DR and BDR will take place. What is router ID? Everything. So here you have got one term, router ID, correct? So what is router ID? It is a 32-bit identification number that is used to identify the router and it is used for DR and BDR election. So what it is? What is router ID? It is a 32-bit identification number. So example can be like it is visible like IP version 4 only. So example can be 1.1.1.1, 2.2.2.2, or any other IPs. Now, what are the methods of getting the router ID? So methods to assign router ID on the router. First is manual method. It means manually assigning the router IDs on the routers, like how we have written here 1.1.1 or as a 2.2.2 like this. Okay. Second method is automatically. In this automatically, the first category is the highest IP address configured on any loopback interface, or we can say, wait a minute, 1 minute. First, you write if we have not configured any router ID on the router, then the highest IP address configured on any loopback interface of the router will be considered as router ID for that particular router. It means what it says, that you have not configured it manually. So the router has to take it from where? Automatically. From where? So it will check highest router ID on the loopback interface. So on the loopback interface, whoever is having the highest router ID will be considered as what? A router ID for that particular router. Okay, for example, let's consider that you have a router. On the interface, loopback 1, you have configured IP as 1.1.1.1. On interface loopback 2, you have configured IP as 2.2.2. On interface loopback 3, you have configured the IP as 3.3.303. So this one will be acting as what? Router ID for the router. Clear?
But what if we have not configured loopback interface?
This is the third criteria. Next condition. Till it is clear? Then we have a next condition. If there is no IP address configured on the loopback interface of the router, then highest IP address configured on any physical interface of the router will be considered as router ID. Clear? It means that if there is no any IP address configured on any of the loopback interface, what will happen? It will take it from where? The highest IP configured where? On the physical interface of the router. Fine. So, for example, if we have a router on this interface, we have 10.1.1.1. Here we have 10.2.2.2. Here we have, like, say, 192.168. 1.5 like this. So highest one will be considered as what? The router ID of the router. If there is no any IP configured on the physical interface, sorry, loopback interface, then. So it means it will check for the first time whom? Loopback. Next, it will check for what? Physical interface. Clear till here? What is DR?
Designated route.
Next, what is the criteria to have this DR? The router with highest priority number will be DR. Okay. And if the priority number on the router is same, that is by default, or you can say that is 1. It means this is the default priority number on the routers, right? What is that? 1 in the OSPF. So if the priority number is same on the router, then the router with highest router ID will be D. Whatever we are writing, it is very important. All the questions can be framed here.
Sir, how will we assign this priority?
Will assign. By default, router is there. By default, it will be there in the OSPF 1 only. We can change that. Okay, so router with the highest priority number will be what? DR. If the priority number on the router is same, that is 1, then the router with the highest router ID will be what? DR. What is BDR? Backup designated router. So router with second highest priority number will be what? BDR. And if the priority number on the router is same, that is 1, then the router with second highest router ID will be what? BDR. That's all. Right? DR and BDR election is required to control the LSA flooding. Is it clear? Then I will ask you one question. You have to tell me. This is router 1. This is router 2. This is router 3. Now make it this one as 3, 4, 5. This is 5. And this is 4. And this is 3. Okay. Router IDs on router 1 is 1.1.1.1. Okay. Priority number on the router is 1. So on the second router, router ID is 2.2.2.2. Priority number is 2. No, wait. One dot one dot one. Priority number is 5. Here we have 2.2.2.2. Priority number is 4. This is going to be 3.3.3.3. Priority number is 3. This is going to be 4.4.4.4. Priority number is 2. And here it is going to be 5.5.5.5. Priority number is 1. Question is, tell me the DR router. Tell me which one is the DR router.
The highest IP address physical interface.
You will tell me just DR and BDR, then I will discuss the concept. Already we have discussed, already I have written there. You just directly tell me which one is DR and which one is BDR according to R1, R2, R3, R4 and R5.
R5 is DR. No, highest priority numbers.
You say that R5 is a DR. Yes, all the students, you are telling R5, right?
Yeah,
All in guys?
R5.
Okay. The DR router is R1.
Because we don't have loopback, right? If you said loopback, if we have, then we can go with.
Hold on 1 minute. Read this statement first.
If the highest priority number will be DR, and if the priority number is on the router is a 1, then the router will be highest router ID will be DR.
If it is not same, then what will be considered? Priority number. No. It is clearly written, if it is same, then election will happen based on the router ID. Here, priority number is not same. Here it is 5, 4, 3, 2, 1. So always for the first time, election will happen based on the priority number. If priority number is same, let's say I will make all the priority as 1 only, then R5 will be the DR because it is having the highest router ID. Clear? Fine, no?
The method we are talking about, that one, if there is no IP address configured on loopback interface of the router, then the highest IP address configured on any physical interface will be router ID user.
Right.
Oh, I got confused about router ID and the priority number. Sorry.
Yes,
Now I got.
We will not check. Router will check. In this, we don't have to do anything. All the things will be router doing. Just we have to understand how it is doing. Clear? Got the idea? What is DR and BD election? How it happens? Fine. Okay. So here, BDR will be router 2 will be the BDR because it is having the second highest priority. If priority number, I will make it all the router as same. then R5 will be my DR and R4 will be my BDR. Then how it will, we have to change, no? Or we can say between them, the election will happen based on the router IDs and remaining will be there based on the router IDs. Okay, priority numbers. Okay, so one more concept we are there. It is there in the OSPF, that is called as a area concept. So see, what is this area concept now? Like as we discussed that we were having certain AS numbers, right? So under the AS number, we have multiple routers. So we can consider that under the AS number also, in the concept of OSPF, we have area. What is there? Area. So it means that if we have routers, let's say these are the routers. So if they are connected and they are belonging to one particular area, so what we say is we give the information regarding the area number. So it can be area 0, it can be area 1, it can be area 2, it can be area 3. What is the number of areas that will come to know? Okay, but they are different areas numbers. Okay, but area 0 is very important. Area 0 is called as what?
Backbone.
Backbone area. So it is called as a backbone area, right? Now the router belonging to area 0 is called as what? Backbone router. Okay, see here that here we have a D3 that is connected with a switch. It is completely belonging to area 0. So we call D3 as what? Backbone router. Correct? Same as if you will see here that here we have D1. So D1 is having one interface this side in the area 0 and other interface in area 1. Getting my point? D1 is having one interface, or we can say some of the interfaces you can consider area 0 and other interfaces in the area 1. So it means it has connectivity in area 0 also, area 1 also. So it is called as what? Area border router. What it will be called as? Area border router. D2, it is having a connectivity between area 0 and same in other area that is called as area 2. It is also called as what? Area border router. It means the router between two different area will be called as a AVR. Correct? Okay. I have a router R2. It is having a connectivity this side in area 2 and this side in area 1. My question is, this router will be AVR or not? Router 2 is having one interface in area 1, other interface in area 2. It means between two different area. This router is AVR or not? Means area border router or not? Yes. According to the concept, or you can say general definition, we can say yes. But according to OSPF, it is not. Why? In OSPF, the router will be considered as a AVR only when it has at least one connectivity in area 0. At least one interface should be in the area 0 and other interface can be in any other area. But if it is there in the area 0 and other area, then only it is going to be called as what? Area border router. So this is not my area router. This is wrong. This question can be asked in the interview. What is area border router? Okay. So this is D3 is called as what? Backbone router. Why? Because it is a part of what? Area 0. Next, other routers, it is called as a AVR router. Why? It is a part of same backbone also. an internal area. And all this B1, B2, B3, and B4 is called as what? Internal router, because it is a part of what? Area 1. Same as all B11, 12, 13, and 14 will be called as what? Internal router, because it is a part of what? Area 2. Area 2. Okay. The router belonging to a single area will be able to communicate with each other. Router coming under area 1. Okay, one more scenario. Then let's say we have router. This 2 router is a part of area 1. Okay. Next, this side also we have 2 routers. It is a part of area 2. Now tell me, this is R1, this is R2, this is R3, this is R4. If I want to have a connectivity between them, can R1 and R3 will communicate? R1 and R3 can communicate? It cannot communicate. It cannot communicate. All these are routers only, but it cannot communicate. How you will be able to communicate a communication between them? Area 0 must be there. It means if routers between 2 different area wants to communicate with each other, they have to communicate via area 0. Okay, so via area 0 only they will be able to communicate. So please remember all these concepts regarding the areas. So it is written here, what is ABR? Area border router. So an OSPF router with interfaces connected to the backbone area and to at least another area will be called as the ABR. Write down this definition and please remember this part. Correct? No? So what is ABR? Area border router. So router having its connectivity between area 0 and any other area is called as ABR. Right? Next is ASBR. Autonomous system border router. The router between 2 different ASN or router between 2 different protocol is called as ASBR. Autonomous system border router, or we can say boundary router as well. Make it boundary router only. Next is area 0 is called as what? Backbone area. The router belonging to area 0 is called as backbone router.
The ABR is also a backbone.
We can say. the router belonging to any other area, then it is called as what?
Internal.
Internal router.
In 8.0, it's a problem that connection of every other.
No, it is not like that. They will not be able to communicate, we can say. But if router of area 0 is not working and other areas are working, so they will have the communication, but they cannot communicate with other area. Internally, they can communicate, no. Internally, they can communicate. Area 1 we have. So 5 router we have in area 1. All this router can communicate, but they will not communicate with outside. Clear till here? So all the definitions are written here. Backbone router is what? A router connected to the backbone area, even it includes what? ABR. Internal routers, a router in one area, not the backbone area, will be called as what? Internal router. Area is only what? It is a set of routers and links that shares the same LSDBs information, but not with the routers in other areas for better efficiencies. It means that's why I'm telling you that they will be forming the neighborship with the routers belonging to a single area. Okay. Backbone area, a special OSPF area to which all other area must connect. And this is area 0. Next is what is intra-area route? A router, a route to a subnet inside the same area as the router. Means if all the communication is happening inside the same area, it is called as what? Intra-area. If two different area, then inter-area. Okay. So today just we have done the OSPF theory only. Even apart from this, we are left with the wildcard mask. So then wildcard mask, then we'll start with the practical of the OSPF. Okay. So what are the things we have discussed today? So first we discuss about the OSPF. In the OSPF, I'm talking states. How many states we have?
7.
7 states. Then packets. How many packets we have?
5.
Okay, see, whatever we are discussing now, in the OSPF, we have network types also. We have different network types in the OSPF. So at present, we are discussing with BMA. What is that? Broadcast multi-access. Okay. By default, whenever you will use OSPF, you will have the network type as a BMA. That is called as a broadcast multi-access. In the BMA, hello timer is 10 seconds and dead interval timing is 40 seconds. 4 times. Dead hello timer is what? 10 seconds. Dead interval timing is what? 40 seconds. If you change hello timer, automatically dead interval timing will change.
Same like 4 times.
4 times. Okay. So one is BMA. Others are like NBMA, point to point to multi-point, and loopback, not there in the CCNA syllabus. Again, it is in the CCNP. Just I wanted to tell you that whatever we are discussing now, it is a concept called as a BMA, broadcast multi-access. It means why it is broadcast multi-access. The reason here it is going to send the update using the multicast address. That's why. And in this, how many packets we have? 7. Sorry, how many states we have? 7 states. When you will come to different types of like NBMA, in NBMA we will be having 8 states. So one extra state is there that is called as an attempt state. Again, same I will discuss in the CCNP part. Clear? Fine. You want me to start wildcard mask?
No, sir.
Okay, so see, tomorrow directly we'll start with the wildcard mask and we'll start the OSPF configuration. So go through all the theory discussion, whatever we have done today. Okay, because directly I will start with what? Wildcard mask and the configuration part. Fine. So we'll stop the recording.